All right, now we're going to look at a couple more rules, and that's the sum and difference rules. And this is pretty straightforward and basic. So if we look here, we have two functions. If we have two functions, f and g, if both of the functions are differentiable functions, which simply means we can take the derivative of f and we can take the derivative of g, then the derivative, again, this is the notation d dx, that says we're taking the derivative of f of x plus g of x, will simply just be the derivative of f plus the derivative of g. Or if we're trying to take the derivative of f minus g, then you would simply say the derivative of function f minus the derivative of function g. So if we look at the example of this below here, we have the problem d dx, which again, this says we want to find the derivative of x squared plus 4x cubed with respect to the variable x. And basically right now you can think of that again as just simply the variable that we have here in the problem is x. So we could think of this problem, again, this is going to make it probably seem really complicated, but just to show you really how easy this is, what we're saying is we could have one function here could be the x squared. So we could call x squared our function f, and the other function g of x would be the 4x cubed. Okay, so basically what we're saying here is if we take the derivative of x squared, the derivative of function f, we multiply by the exponent, so that's 2x. If we decrease it by 1, that would be 2x to the first power. And we could just, you could write a 1 here, but we know that's understood to have an exponent of 1. And we could take the derivative of g, so we find g prime of x Three times 4 is 12. X, subtract 1 from the 3 is 2. So here you have the derivative of f, the derivative of g. So now if we here, this would be equal to f prime plus g prime. So in other words, we could simply write 2x plus 12x squared. Okay, and there's your answer. Now again, that's kind of the long drawn out. Simply what we're saying is if you have two functions and you're adding them together and you're taking the derivative, you can think of taking the derivative separately, or really all we're doing here with this example is if we want to find the derivative of x squared plus 4x cubed, and we'll make this one really easy, you can just simply take the derivative of each term separately. So for example, we want to take the derivative of x squared. We know that's going to be 2x, and then plus the derivative of 4x cubed, which is simply 12x squared. Okay, so over here when I was writing all of this stuff out over here, that's just kind of giving you a visual example of what we're doing, but you do not need to write all of that out. You just simply take the derivative here of each of these terms separately. So x squared would be 2x, and then 3 times 4 is 12x squared. So if I give you another example here, we want to find the derivative of, let's say, 9x cubed minus 4x squared plus 6x plus 3. Now again, we don't have to define these. I mean, typically you could, or technically rather, you could think of these as 4 separate little functions, but we could just think of this as, well, we can easily take the derivative by simply taking the derivative of 9x cubed. So we would have 3 times 9, which is 27x, and we decrease the 3, so that becomes 27x squared. And be careful here, it's minus, and 2 times 4, so therefore we have 8x. And if we subtract 1 from 2, where exponent is 1, And now we have, keep in mind, this is what? Exponent of 1. So 1 times 6, we get 6. And if we subtract 1 from the exponent, we end up with 0. So we would technically have x to the 0 power. But if anything is raised to the 0 power, that is equal to 1. So we could just simply write 6. And if we take the derivative of, so I guess I could write that in there, we would have x to the 0 power. And if we take the derivative of plus 3, we're taking the derivative of a constant, and once again that's going to always be equal to 0. So really all we're going to have is 27x squared minus 8x plus 6. And that's basically all that we have here when we're looking at finding the derivative using these sum and difference rules. So really you're just simply taking the derivative of each of the individual terms. So we'll just look at maybe a couple more examples here. To review a little bit, if we had, say, for example, f of x equals 8x cubed minus 5x squared plus 2, and I want you to find the derivative. And once again, this is a place where you may want to pause the video and see if you can work out this and find the derivative on your own. So here, if we want to find the derivative, we can simply take the derivative of each piece. 3 times 8. We're going to take the exponent and multiply to get 24x, and the 3 is decreased by 1, so it's 24x squared, minus, we take the exponent, 2 times 5 is 10x, and we decrease the exponent, so therefore it's 10x to the first, or simply 10x. And of course, once again, the derivative of a constant is 0, so this is your final answer. And we will look at one more example here. Let's say f of x equals 5x cubed minus 5x squared. And let's say that here we want to evaluate this, we want to find the derivative f prime of x. So we would take 3 times 5 and we get 15x squared minus 2 times 5 is 10x, and we reduce the exponent 2 to 1, so we end up with a minus 10x. So this is our derivative. Now what if I went a step further and I said we want to find, let's say, f prime of 4. Well, this simply means we want to find the derivative, or f prime, we want to find the derivative evaluated at 4. Well, that means we would simply say, well, here's the derivative. And we want to plug 4 in for x. So you would get 15 times 4 squared minus 10 and plug 4 in for x. So then if you multiply this out, you're going to end up with 200. So what does that tell us? Well, once again, what we have found here, if we go back to our function, f of x equals 5x cubed minus 5x squared. This is the graph of our formula for our function. We take the derivative, and keep in mind, what does the derivative tell us? That gives us the slope. So this is kind of the slope formula for this function f of x. And now, by plugging 4 in to the derivative, we found the slope of this function when x is 4. So here we found the slope of the function at 4 is going to be 200. or again, instead of slope, you could think of that as the rate of change. So when x is 4, the rate of change is, think of this as 200, remember, of your slope over 1. So this says that your y value is changing 200 units as your x changes 1. So basically this means you're going up 200 over 1. So here your y is changing at a much faster rate than your x value. So remember, this is representing your change in y over your change in x. So always keep that in mind. Everybody starts to lose sight of what the derivative is really finding. So this whole process, when we find the derivative, we're finding a formula basically for the rate of change of this function. Or in other words, when we say the rate of change, we're finding that instantaneous rate of change of the function at a particular point, and the point we're looking at here in red is 4. So when x is 4, the graph is changing at a rate of this 200 over 1. So the y is changing 200, your x is changing 1.